Hi, I'm Pranati Srivastava. I'm taking this course, Special Topics in Cryptography online, and I'll be presenting functional encryption to you through this video. Getting started, what is functional encryption? Functional encryption is a modified type of public key encryption. Here, if we know the secret key of the secret key, then we could decrypt only a specific function of the whole encrypted message of the ciphertext that we have. The This topic is fairly new and has not been not all in its application is not very well defined in all the on all types of ciphertext. So talking in general, this allows us to decrypt only the parts of the encrypted data rather than decrypting the whole text, because whatever encrypting technologies we have available right now encrypt either the whole message and decrypt the whole message back. We have nothing available that just works for part of the data. So one example to explain this would be that if we give some encrypted program, user wants to decrypt one encrypted program, but he has a secret key. The owner of the program does not want the user to see the code of the program. He just wants him to see how it works, see the output probably. So the secret key which the user would have would only decrypt the output of the program without revealing any of the codes that hidden, any of the code that hidden that's written for the program. So that is what functional encryption is basically. That it just applies secret key on the function of the data and not the complete data that has to be decrypted. Now, need of functional encryption. We needed functional encryption for the pretty much same reason that it could help us to decrypt only parts of the whole data. And before the advent of public key encryption, the communicators, when they had to communicate data secretly, they used to use secret key amongst them. But this key was mutually shared amongst the communicators. And then later, when public key encryption was invented, sharing data over internet and such large networks made it impossible for users to mutually share the secret keys. So then public encryption came into picture, and everybody had a public key and a private key. The challenges faced in public key encryption is that either the complete message was decrypted or nothing was. So, in modern day technologies such as targeting face pictures on cloud and decrypting just parts of the complete message, functional encryption was there to solve this problem. This talks about where there are big databases of images stored on cloud, and then if any investigating organization, probably like FBI, just wants to look for faces of a particular person. So to be searching cloud, all the data on cloud, they just need particular target face. But if they use their secret key and decrypt the whole data, it would be giving them all the information which need not be needed. So for that, functional encryption might be used. How does functional encryption work exactly? So, in a system using functional encryption, a decryption key is used to find the function of the encrypted data. In a functional encryption system, for a functionality such as this, which is a function of two things, the master authority is in possession of the master key, and the person who has the master key can create a secret key. We denote the secret key here as this. So this key can now compute the function which is a combination of the key and the thing you're applying the function to on the ciphertext. So using secret key, the key used for decryption can compute the function f of kx from an encryption of x, which is your ciphertext in this case. So functional encryption makes sure that no information about the X other than the function of X would be available to the user with the particular key that you're sharing with them. Moving on to the formal study of functional encryption. A functional encryption scheme for a functionality F defined over K and X is a tuple of four PPT algorithms which involve four steps like setup, key generation, encoding, and decryption, satisfying the following correctness condition for all the keys that belong to the class of key and all the X that belong to the set of X. So these are the four steps in functional encryption are setup, key generation, encoding, and decrypting, which is being shown here. So in this case, a public key and a master key pair are being generated. So this is the setup step where a public master key and a secret key is being generated. Then moving on, the second step is key generation. Here the secret key would be generated using the master key. And then we are encrypting our data using our public key and the data we want to encrypt, that is our X. So we are encrypting our message X. And we use the secret key here in this case to decrypt the data back using the function f. Used a case study to think about to see how functional encryption is really getting applied in today's new technologies. So this is a in this case study, functional encryption was used to resolve security issues in cloud environment, and this is a joint research conducted with NTT and Mitsubishi Electric. In So companies which use cloud computing, they have lot of data to be transferred and lot of confidential data to be outsourced to other servers. So to secure this data while they're transferring it to any outsourced server, they needed some security scheme. So in joint research conducted by NTT and Mitsubishi, as I said earlier, used functional encryption, and this functional encryption was a special type of functional encryption called the attribute-based encryption. Here, the attributes of the data were used to encrypt the whole data, and it incorporates into ciphertext itself a function that restricts access rights to the ciphertext. So here the function is restricting the ciphertext itself inside it. So moving on, yeah. To make the information available to all the members in the company, we would have to generate multiple ciphertexts and decryption keys. So if everybody in the company had to be using the data from the cloud, multiple ciphertexts would have to be generated and multiple decryption keys have to be distributed amongst all the members of the company. So here, this schemes make sure that a single ciphertext and the same decryption key, if a single ciphertext and the same description key were to be used and distributed amongst the members of the company, it might have been misused. So the attribute-based encryption used here, which is a type of functional encryption, make sure it incorporates conditional statements in the ciphertext itself, and the ciphertext is restricted, has access rights, and restricts the hi again. There was a short pause in the video, so I'm starting with this point over here again. The attribute-based encryption used here incorporates conditional statements in the ciphertext itself. So this restricts the access rights to the information over the data. So instead of having multiple decrypting keys and multiple functions accessible for different job posts in the company, giving them access rights to that data over the cloud, what attribute-based encryption here did was it was able to incorporate the conditional statements into the ciphertext itself. So when in the ciphertext all the writes and the attribute information was stored in the information in the ciphertext. So when the key was applied to decrypt that, the ciphertext already knew who was trying to access the information and decrypted that part only if the condition of the attributes were satisfied. So in this picture, I show the same thing. There's a cloud server. The cloud server, here the data is being uploaded using by the person who has the public key, and he is the probably he's the master. He has the master key as well to generate the secret keys for the other members of the company. So here the condition that is being set by the data uploaders are human resources and human resources department and section manager or the general manager. So what this condition would say that either you should be a section manager in the human resources department or a general manager in any of the other departments. So when the system administrator is trying to decrypt it, he isn't able to decrypt the data because that's not, the condition does not satisfy. And this function is encrypted in the data itself. So it's not based on what kind of key the user is using. So now here, this user has the private key and he's the section manager in human resources department. So he is able to decrypt the data. But again, when there's another section manager who is a part of the general affairs department, he isn't able to decrypt the same data because it doesn't satisfy this condition. So yeah, the attribute information might include a company name, department, and position, and they're using conditions like and, or, and not to control the access rights over the data. This example describes the same thing as in the picture. So with attribute-based encryption, a single ciphertext which incorporates a complex condition can be decrypted by multiple keys which include employees' attributes. And the system therefore not only ensures security but also reduces a lot of labor involving in generating multiple number of ciphertexts and multiple number of keys. And it reduces the data involved in contributing to reducing the costs associated with outsourced servers. That's about it. Most of the topics that we spoke about in my presentation was taken from Functional Encryption, Definitions and Challenges by Dan Bonet from Stanford, Amit Sahai from UCLA, and Brent Waters from University of Texas, Austin. I've also used some other references that are being used here. My case study was picked from MitsubishiElectric.com. Thank you. Have a nice day.